So in this video, we're going to look at a case where we have the indeterminate form 0 times infinity and talk about how to deal with these types of indeterminate forms. So the big idea is there's additional indeterminate forms that we haven't talked about yet. And these are indeterminate forms in the sense that the form 0 times infinity, infinity to 0, infinity minus infinity, 1 to infinity, they're indeterminate in the sense that the forms don't lend themselves to interpretation in regards of what the limit is going to be. So sometimes when we get an indeterminate form that looks like this, to which L'Hopital's rule can't be applied because L'Hopital's rule requires the indeterminate form is a ratio, but we may be able to manipulate the function that has this form into a form to which we can apply L'Hopital's rule. So let's look at this one right here. We have the limit as x goes to 0 of x cubed times the cotangent of x. And what we want to recognize is that it has a specific form. So the form is the limit as x goes to 0 of x cubed would be 0 times, and the limit as x goes to 0 of the cotangent function is infinity. As x goes, and this should actually be x going to 0 from the positive side. So that's a typo in the slide. X goes to 0 from the positive side. The cotangent function sweeps up along the x-axis. That's horrible. So as x goes to 0 from the positive side, the cotangent function goes to infinity, and then the picture repeats itself. So as x goes to 0 from the negative side is actually going to negative infinity. So I have to specify the side from which I'm approaching 0. So the limit as x goes to 0 of x cubed times the cotangent of x has the form 0 times infinity. I can't apply L'Hopital's rule to this because I don't have a ratio, but I may be able to manipulate into a form that does allow me to apply L'Hopital's rule. So I have the limit as x goes to 0 from the positive side of x cubed times the cotangent of x equals the limit as x goes to 0 from the positive side. And I want to recognize that the cotangent is just the cosine over the sine. So I can rewrite this right here as x cubed times the cosine function. So cosine of x over the sine of x. And then I can ask what form does this have. So the form of this, as x goes to 0 from the positive side, the sine of x, or the sine of 0, is going to be 0. So I have a 0 in the denominator, and I have cosine of 0 as 1, and as x goes to 0, x cubed goes to 0, so I have 0 times 1, so the form is 0 over 0. So clearly this is a form to which L'Hopital's rule can be applied. So applying L'Hopital's rule, we get equals the limit as x goes to 0 from the positive side, and then we need to take the derivative of the denominator, and the derivative of the sine function is the cosine function, so cosine of x. And then we have to take the derivative of the numerator, so I'm going to need to apply the product rule on the numerator. So I get the derivative of x cubed is 3x squared times the cosine of x, plus I get x cubed times the derivative of the cosine, which is minus the sine function. So the minus will go right here. And then I want to look at this and ask myself the question, can I evaluate this limit? It looks nasty, but what I want to realize now, if I were to plug 0 into the denominator, I get the cosine of 0 as 1. I don't get a division by 0. So it's going to be okay for me at this point to drop the limit notation and plug the 0 into the ratio. So I get 3 times 0 squared times the cosine of 0 minus 0 cubed times the sine of 0 all over the cosine of 0 equals, and the 0 here and here will completely zero out the numerator, and the cosine of 0 is 1, so I get 0 over 1 is 0.